Okay, so first let's make the correction. This should not be AAS right there. This is on the top right here, we're saying the angle side angle posture. This box also should say the angle side angle, or the ASA posture. And because the S is in between the two A's, we know that we're going to have an included side that is touching two marked angles. Okay? Trying to get the correct sign. So, yeah. Two angles, so the same, and one included side. It's included because it's in between the two angles. And one triangle are congruent to two angles and one included side. On the second triangle, these triangles are congruent. So the ASA is working like a map. We have an angle and a side and an angle. The S is touching both A's, so we know that the marked side is going to touch both marked angles. Okay, so here's the example. You can see that we have an angle marked right here. Marked with an A. Same angle is marked in the other triangle, so I'm going to mark with an A. I have two lines, so that's a side. Two lines, so that's a side. And that's all that is here, but I also know that vertical angles are congruent, and these are vertical angles. So I know they're congruent, so that gives me another A. So just like it's written in the box, ASA postulate, we have ASA right in a row. Nothing skips. There's an angle, then there's a side, and there's another angle. The marked side is touching both angles. The side is touching both angles. The S is touching both A's. So that's why you know this is the angle side angle. And what's the congruent part? There's no letters here. Yeah, we'll just take that off. Do it that. So the reason why is the angle, side, angle, postulate. So then the next one is the angle, angle, side. So we're good. You can tell, again, by looking at the letters, we have angle, angle, side, AAS. The X is only touching one A, so the marked side is only going to touch one angle. All right, so if two angles and one non-included side of one triangle are congruent to two angles and one non-included side of the second triangle. congruent. Again, I'm not going to list congruent parts because I didn't label triangles. But I want to explain why these two triangles are congruent. So I need to see, what do I have? I have an angle with one line and another angle with one line. So they each have an angle that is marked with one line. This one's marked with an A for angle. I have an angle marked with two lines and another angle marked with two lines. So they are the same. So there's another A for angle. And then, since they share a side, I know that the shared side is congruent to itself. So I can mark it as congruent, and that's the side for both triangles. And it doesn't matter if you read clockwise or counterclockwise. Clockwise is C. If I read counterclockwise and I get AAS, if I read clockwise, it's SAA. So this is you get different letters, but they both do the same thing. The side is only touching one of the A's, it's not touching the other A. And I've been saying there's no gaps when you're reading, and there is slightly, like I don't have to. It looks like there's a gap from A to A, but the gap is a side. I'm not skipping another angle between A, I'm not saying angle, skip that angle and another angle. So it works. So you could be SSA or AAS, it's the same thing. So you probably want to write that down up here. It could also be SAA, side angle angle. Same thing. It depends on which direction you're reading, clockwise or counterclockwise in the triangle. Angle angle side or side angle angle mean the same thing. So I know that the triangles are congruent by the angle side postulate. So the third one for today is the hypotenuse leg postulate. And this one is special. You have three conditions that have to be met. So let me go through it first. If the hypotenuse and leg of one right triangle, so this is only for right triangles. You only have a hypotenuse when you have right triangles. Hypotenuse is the long side with across from 90 degrees. It's only in a right triangle. Are congruent to the hypotenuse and leg of a second right triangle, then the triangles are congruent. So you do have to have right triangles. Only true with right triangles. Right triangles have two legs and a hypotenuse. If you're not familiar with which one is the hypotenuse, the long word goes with the wrong side. So the hypotenuse is the long side. And then you have the other two are legs. The straight, vertical or horizontal, those are legs. And as long as you have one leg marked and the hypotenuse marked and 90 degrees marked, then you know that you can use the HL postulate, the hypotenuse leg postulate. So explain why the triangles are congruent and not looking apart. Again, let's see what we have to start. I have, first, if you're going to use HL, you're only going to use it with right triangle. So first make sure that this is right, with the 90-degree mark. And it's vertical angle, so I know that the other one is also 90 degrees. So I have two right triangles. And then I see, do I have the hypotenuse marked, and do I have at least one leg marked? So two lines, that's a leg. I have a leg and a leg. And then for 90 degrees is the hypotenuse, and I have it marked with three lines. So I have the H. So yes, I have a matching hypotenuse. One of the legs we know are matching. They're both 90 degrees. So this is congruent by HL postulate. So that's the three we're going over there. HL, angle, side, which is also SAA, AAS or SAA, doesn't matter which way you say it, and angle side angle. Two angles on the side with the side in the middle, two angles on the side with the side on the outside. Right triangle has its own HL, and now I have some samples to go through. For each diagram, determine if each pair of triangles is congruent and by which postulate. So do we know if it's congruent, and if so, how? All right, so number one, those are not 90 degrees, so these are not right triangles, so I know they're not congruent by HL just off the top, just by looking at it. And just because it is 90 degrees doesn't mean you're going to use HL. It may be some other postulate, or none at all. So I have an angle. Both have an angle marked the same, and they both have a side marked the same. There's nothing else marked, but we know these are vertical angles because they have that bow tie shape. Vertical angles share a vertex, so they're the same, and that's another angle. So I know that, yes, these are congruent. By, I have two A's and an S. The S is the side is only touching one of the A's. So here, if I look at this side, it's only touching the green A, it's not touching the blue A. So this is AAS. Angle, side. All right, so the next one line angle, one A. Two line angles, so those are A's, they're angles. They share a side. We know shared sides are always congruent to itself. So it's an S on both of them. The S is touching both A's. This is ASA. So these triangles are congruent by ASA. In the picture, the side is touching both angles. So the S is going to touch both A's when I write my postulate. All right, so number 3, I see 90 degrees, so it may be HL. Associate HL with 90 degrees. Doesn't mean it always will be, but we just know to check for it. So this is marked as 90, and because this is a straight line, it's 180 degrees, and if it's split into two angles, and one of them is 90, then the other one has to also be 90. So that means that this one is also 90. We have the hypotenuse is marked as congruent, and they share a side, which is a leg. So 90 degrees, always look for HL first. You have H, you have L, you have H, you have L. All right, so we just said SSA. SSA, remember that looks like this, and that's the easiest way to tell that that's not the correct answer, right? So no, not the correct answer. That's not a postulate. But it does have an H and an L, an H and an L, so this is congruent by HL. And sometimes there's more than one way to say they're congruent. And for HL, I guess you would pick HL because that one's special. But, it would still be true if you picked any of them. If it was multiple choice, then you shouldn't have two options that are both true. But there could be more than one way to prove triangles are congruent. All right, so the last one, we have an angle marked with one line. An angle marked with one line. And those don't really look like they match up, but they're marked that way, so I guess we'll go with it. And then we have a side marked the same. Those aren't, why would we mark like that? Those are not the same parts of the triangle. But it says they are. And then they share a side. All right, so we have to look at this one because we know those are the same, and we know that they share a side, and they have a side marked the same. So let's label this. Let's check those triangles. So looking at the bottom triangle, that's an angle. This is a side, and another side. And on the top one, we have a side, and an angle, and a side. So on the top triangle, we have SAS, and on the bottom triangle, we have ASA. So those do not match. The top one looks like it's going to give us a congruency postulate, but the bottom one doesn't match it. So this is not congruent. So you do have to check both of the triangles to make sure they both give you the same order of letters. So then the last section on the note says what additional information is required in order to know that the triangles are congruent for the reason given. All right, so if we want to say that number 5 is congruent by HL, hypotenuse side, what else do we need to know? All right, so to determine what else we need to know, we need to first determine what we do already know. We already know that they are right angles, so we know they're right. And H is the hypotenuse, L is the leg. This shared side, that's a leg. So that means we need to know the hypotenuse. The hypotenuse is always across from 90 degrees. So we need to know that this side matches this side. That's what we need to know. So to write that, we would say we need to know that PU, side PU, is congruent. Now we match SG. We get them in the same order. PU, we need to know that PU is congruent to SG, which gives us the hypotenuse. Okay, so the next one, we want to know that these triangles are congruent by the angle side postulate. So first we're going to see what do we know. We have an angle P is marked with one line. Angle U is marked with one line. And we have side RQ is congruent to side TX. So we have one side and one angle. We want the side to touch only one of the angles. Right now the side isn't touching either one of them. So really we can say this either way. There's two answers here. It could be that R is congruent to T. That's one answer, because then we would have angle, side. angle R is congruent to angle T. Or if we knew that Q was congruent to S, that would also give us angle psi. So there's two possible answers there. And then the last one, to prove that this is angle side angle, this is what we have. We will know that angle H is congruent to angle B. Angle. We know that angle I is congruent to angle E. Those are angles. So if we want angle side angle, the S is touching both of the A's. So we need the side that's touching both angles. So between the two A's, we would need to put an X. Between the two A's, we would need to put an X. So for this one, we would need to know that HI is congruent, H is 1, B is 1 to BE. And that would prove angle side angle. So you're looking at the